Have you ever wished you could be just a little bit lighter, maybe lose a few pounds without hitting the gym? Well, what if I told you there's a place on Earth where you actually weigh less? No, it's not a magic trick, and it's not a new diet fad. It's a real phenomenon, backed by science, happening right now in a specific spot on our planet. Today, we're going on an incredible journey to uncover this mysterious place where gravity seems to take a little break. So, where is this magical spot? It's not on top of the highest mountain, as you might guess. It's actually in the middle of the Indian Ocean. Scientists call it the Indian Ocean Geoid Low, or IOGL for short. This isn't just a tiny spot, it's a massive area, spanning over 3 million square kilometers, where the pull of gravity is significantly weaker than anywhere else on Earth. So what does weaker gravity actually mean? Let's break it down. When you step on a scale, you're not measuring your mass, which is the amount of stuff you're made of. You're measuring your weight, which is the force of gravity pulling your mass down. Because the gravity is weaker in the Indian Ocean Geoid Low, if you could somehow stand on a scale floating in the water there, you would genuinely weigh less than you do at home. The difference isn't huge. You won't float away, but it's measurable and scientifically fascinating. But the most visible effect is on the ocean itself. In this region, the sea level is actually about 106 meters, or 348 feet, lower than the global average. Imagine a giant, invisible hole or dip in the ocean. That's essentially what the geoid low is. It's not a physical hole you could fall into, but a depression in the planet's gravitational field that pulls the water down with it. For decades, this gravitational anomaly has been a huge puzzle for scientists. How could such a massive area have such low gravity? Early theories ranged from strange mantle dynamics to leftover echoes from the Big Bang. It was a genuine mystery of our planet's inner workings. But recently, a groundbreaking study from the Indian Institute of Science in Bengaluru might have finally cracked the code. Researchers used supercomputers to simulate the geological history of our planet over the last 140 million years. That's a huge timescale, going all the way back to when dinosaurs roamed the Earth. Their models showed something incredible. The key to understanding the Indian Ocean's gravity hole lies deep beneath the Earth's surface, in the mantle, the layer between the crust and the core. Let's rewind the clock a bit. About 120 million years ago, the ancient supercontinent Gondwana was breaking apart. What is now India began its long journey northward. As it moved, it passed over a slab of an ancient ocean floor called the Tethys Sea. This slab of oceanic crust was colder and denser than the surrounding mantle, so it started to sink. As this Tethys slab sank deeper and deeper into the Earth's lower mantle, it displaced the hot, less dense molten rock around it. This displaced material, known as a mantle plume, began to rise. Think of it like dropping a heavy rock into a bucket of honey. The rock sinks, and the honey around it gets pushed up. These rising plumes of hot, low-density rock from deep within the Earth are the real culprits behind the gravity hole. Here's the crucial part. Mass creates gravity. The more mass there is in a certain area, the stronger its gravitational pull. Since these plumes are made of hotter, less dense rock, they have less mass than the surrounding cooler, denser material. The computer simulations showed that these plumes of low-density material spread out beneath the lithosphere in the Indian Ocean region. This massive pocket of less dense rock deep underground is what creates the mass deficit we observe. With less mass concentrated underneath, the gravitational pull at the surface becomes weaker. This explains both the dip in the ocean's surface and the measurable decrease in gravity. So, the Indian Ocean Geoid Low is essentially a shadow cast by what is happening hundreds of kilometers below our feet. It's a story that connects the ancient dance of continents, the sinking of a long-lost ocean, and the slow, powerful churning of our planet's interior. The researchers' models were the first to show the whole sequence of events in a plausible way, linking the sinking Tethys slab to the rising plumes that ultimately formed the geoid low. Their simulation beautifully recreated the anomaly exactly where we find it today. This discovery isn't just about solving one puzzle. It gives us a powerful new tool to understand the hidden geology of our planet. The Earth's mantle is a dynamic, ever-changing place, and phenomena like this give us a rare window into its behavior. It shows how events from millions of years ago can still have a visible, measurable impact on the world we live in today. But what happens next? Will this gravity hole be there forever? According to the same computer models, probably not. The plumes that are causing the geoid low are still active, but like all geological processes, they won't last forever. The researchers predict that the gravity anomaly will likely dissipate over the next few million years. So, while it's a defining feature of our planet today, it's just a temporary chapter in Earth's long and epic story. It's a powerful reminder that the ground beneath our feet is not as static as it seems. It's constantly in motion, driven by immense forces deep within the Earth. So, the next time you look at a map of the world, remember that it's not just a flat picture. It represents a dynamic, three-dimensional planet with invisible hills and valleys in its gravitational field. And in the middle of the Indian Ocean lies the biggest valley of them all, a place where the Earth's pull is just a little bit weaker. All thanks to the ghost of an ancient ocean and the fiery breath of the planet's core. It's an incredible story of planetary science that connects the deep past with the present. And it shows that there are still so many wonders left to discover about our own home. Thanks for joining me on this deep dive into one of Earth's biggest mysteries. It is amazing to think about the complex forces that shape our world in ways we can't even see. If you enjoyed this journey and want to explore more scientific wonders with me, make sure to hit that subscribe button and turn on notifications so you don't miss our next adventure. Until then, stay curious,